Identify if the given molecules are polar or non-polar. Alright, we're going to start with this one. So SO3. has 6 electrons, and O has 6 as well. But since there's 3 of them, multiply it by 3, which gives you 24. Alright, now we're going to draw the structure. So O, S, 0, O. Alright. S is the more positive atom, so element. So it's going to have the more partial positive charge. So, alright. So each bond is going to be 2. So 24 minus 6 give you 18. And we're going to start with the outside atoms. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 6. Which is 18. Which will give you 0. Due to this, S does not have an octet. So you would have to take away 2 electrons and draw a bond right here to satisfy the octet. And due to this, you can do this to every oxygen, so the resonance structures will look like this. That would be the resonance structures for each one. So as I said before, S has the more partial positive charge, so like this, and oxygen would have the, that's so bad. Oxygen has the more partial negative charge, so that'll be it. The dipoles for this will be pointing away from the more positive one, pointing towards the more partial negative atom of oxygen. And due to this, each one of the dipoles cancels out, so that there will be no net dipole, and it will be non-polar. So SO will be non-polar. Alright, that took way too long. Alright, for the next one, we would do OF2. So OF2, oxygen obviously has 6 electrons that we said before, and fluorine has 7, and since there's 2 of them, you multiply by 2, which will give you 20 electrons. So for the structure, we would do O, F. That's how you draw it. And the bonds are 2 each. So it would be 4 minus 4, which will give you 16. So next we would start with the outside atoms. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And you have 4 left over. So you do 1, 2, 3, 4. So that would be the Lewis structure. And so oxygen is the more, oxygen is the more partial positive charge, and fluorine is the more electronegative, so it would be more partial negative. And dipoles would point towards the more negative atom, like that. And these non-bonding electrons up here would give you a net dipole pointing down. These would cancel out, so there would be a net dipole pointing down, so therefore it would be polar. So OF2 is polar. Copy that. Just to completely erase the P. Alright. Next, we would start with BeCl2. and Be is 2, has 2 valence electrons, and Cl2 has Cl has 7, and since there's 2 of them, you multiply by 2, which will give you 16 valence electrons. So when we draw this out, it will look like this. Each, like I said before, each bond has 2, so it'll be 16 minus 4 equals 12. So then we would start with the outside atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There will be 12. Be does not have to follow the octet rule because it is indeed an exception. So Be is the more partial positive charge, and chlorine is the more negative atom. So therefore, the dipoles would be pointing towards the more negative atom. Due to this, each dipole cancels out. Therefore, there is no net dipole, and therefore it is non-polar. So BeCl2 is non-polar. All right. Next, we will do CCl4. This one. Has 4 valence electrons. Carbon has 4 valence electrons. And chlorine has 7. Since there's 4 of them, we have to multiply by 4, which will give you 32 valence electrons. Next, we will draw the Lewis structure. You draw it like this. Cl. Alright. Like I said previously, each bond has 2, so it would be 8. So it would be 32 minus 8, which would give you 24. And now you would start with the outside atoms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That would be 24 on the outside atoms, and therefore it would have 0 valence electrons left. And that would be it. So carbon has the more partial positive charge, and the Cl has the more partial negative charge. So therefore, the dipoles would be pointing towards the more negative atom. And thus, each dipole will cancel out, so there will be no net dipole, and the CCl4 would be non-polar. And that would be non-polar. Last but certainly not least, we have O3. Oxygen has 6 valence electrons, and there's 3 of them. So you multiply by 3, so it'll be 18. So when we draw it, it would be like this. Alright, so then we start with the outside atoms. Oh, I'm sorry. So each bond has 2, so it'll be 18 minus 4, which will give you 14. So we would start with the outside atoms. That'll be 12. 14 minus 12, we have 2 left, so you put the 2 remaining non-bonding electrons on the center O. Due to this, oxygen has to follow the octet rule, so you will remove 2 electrons and you add the bond there. Due to this, you would have another resonance structure on the other side, so it would look like this. That would be the resonance structures for this molecule. So next, the dipoles. Alright, so I'm going to redraw this since it would look like this. So that would be the true Lewis structure. And the dipoles will be pointing down here, and due to the non-bonding electrons at the top, the net dipole will be pointing down, so it would be polar due to the net dipole. And all the domains are not equivalent, so it will be polar.